Welcome to today's lesson. Previously, we've been looking at multiplying positive integers that are small, but today we are going to look at multiplying large positive integers. So when you are multiplying large positive integers, you choose a suitable multiplication algorithm method, depending with what figures you've been given. So the first way in multiplying large positive integers is when multiplying by 10 or the powers of 10. So when you're multiplying by 10 or the powers of 10, what simply happens is the digit moves to the left by the number of zeros that are available. So if, for instance, you are having 12 times 10, if we have 12 times 10, then we only have 1 0. The digits that we are having here is 1 and 2. So 1 and 2 will move to the left by 1 step because of the 1 0. So that the 0 is now the one to the farthest end. So that we will have 0, then 2 moves 1 step, so it will become in the tens place value. Then 1 moves to the 100s place value. So we find that 12 multiplied by 10 will simply give us 120. So if you take another example, and maybe we are having 16 multiplied by 1000. So we are having 3 zeros. That will mean that our digits will move behind or to the left by 3 steps because of the 3 zeros. So we write the 3 zeros, then move our digit, that is 6 and 1, so that if we are having 16 multiplied by 1000, we are going to obtain 16,000. If we have 45 times 100, then we have 2 zeros. It means our digits are going to move to the left by 2 steps because we have 2 zeros. So 45 times 100 will give us, we write the 2 zeros, then we have 5 and 4. So the answer to 45 times 100 is 4,500. So that is involving multiplication by 10 or the powers of 10. So the powers of 10 in these examples we have, the first one we are having the 10 itself, then we have 1,000. 1,000 is simply 10 to power 3. Then we have 100, which is 10 to power 2. So we've multiplied our numbers by 10 or the powers of 10. The next step is multiplying by multiples of 10. So when you are multiplying by multiples of 10 or the multiples So we have multiples of 10 or the multiples of the powers of 10. What we do in this case is you'll first multiply by the number that is before the zeros. So if you're having, for instance, we are having 2 multiplied by 300. 300 is a multiple of 100, which is a power of 10. So we are having to multiply 2 times 300. We can start by multiplying by the number before the zeros. That is 2 multiplied by 3. Then the multiple of 10 that is here is 100, so it means we then multiply by 100. So this 2 times 3 is simply 6, then multiplied by 100 gives us 6 times 100, which is 600. So when you're having 10 or multiples of 10 or the multiples of the powers of 10, you simply first start by multiplying by the number before the zeros, then you add the zeros on the given answer that you will get. Another example could be we are having 62 times 500. 62 times 500, 500 is still a multiple of 100. So it means we start by multiplying by the number that is before the zeros. And the number that is before the zeros is 5. So we are having 62 multiplied by 5, then times 100. 62 times 5, you are going to obtain, that is 2 times 5, that is 10, carry 1, then 5 times 6, we get 30, plus 1, that is 31. Then we add on the 2 zeros on 100, so that means we add the 2 zeros there. We're going to obtain the answer as 31,000. So 31,000 is our answer when we multiply 62 times 500. We can look at another example. Example 3. So if we have 52 multiplied by 6,000. So we are having 6,000 is a multiple of 1,000, and 1,000 is also a power of 10. So we've said you simply start by multiplying the number that is before the zeros, then the answer you obtain, you add on the number of zeros that we have. So we are having 52 multiplied by 6, then we multiply the answer obtained by 1,000. So 52 times 6, we are having 2 times 6, that is 12. Then 6 times 5, we get 30. We carried 1, so plus 1, we get 31. Then we add on the 3 zeros that are on 1,000. So we get that 52 times 600 should give us 312,000. So that is multiplying a number by multiples of 10 or the multiples of powers of 10. Another suitable method that can be used in multiplying large positive integers, we have the algorithm of multiplying the integers, and this involves the following procedure. So if, for instance, we are having 275 and we are multiplying it by 17, the first step that we are supposed to do is we are supposed to multiply from the right side. So as we are having multiplication from the right hand side, we start with the digit in the ones place value. So starting with the digit in the ones place value, it means I'm going to have 275 multiplied by 7. So we are having 275 times 7. That is the first procedure that we have. The digit in the ones place value of the second number is going to be going to multiply the numbers that we are having as our first digits. So as we multiply 275 by 7, we follow the normal procedure that we used when you are having small positive integers. So this means I'll have 7 multiplied by 5, that is 35. I write 5, carry 3. Then 7 multiplied by 7, we get 49. 49 plus 3, that is 52. So write 2, carry 5. Then we have 2 times 7 will give us 14. 14 plus 5, we are going to get 19. So we get that 7, when we multiply 275 by 7, we are going to obtain 1925. So we write it in that order. Just from the last figure is just below the 7 digits. So we are having 1925. This is simply 275 multiplied by 7. Then the next procedure, the next digit that we have is 1. 1 is in the tens place value. So it means for me to get the values that are being obtained in this case, then being in the tens place value, I'm having 275 times 10. 275 times 10, we are having multiples of 10. So being the fact that this is a 10, we simply add a 0 on that. So we'll get 2,750. So we write it at this position so that our 0 starts from that point. We have 5, we have 7, then we have 2. After we've multiplied the two numbers, what is the next step that we have is addition of the two numbers. So we add the two numbers that have been obtained. This means that I have 5 plus 0, which will give me 5. Then we have 2 plus 5, that gives me 7. 9 plus 7, we get 16. So we write 6, carry 1. So I'm carrying 1. Then I have 1 plus 1, that is 2. 2 plus 2, we get 4. So it simply means 275 multiplied by 17, the answer obtained is 4,675. So that is the multiplication algorithm procedure. You will start with the digit in the ones place value, multiply and get the answer, write it in the first line. Go to the digit in the ones place, in the tens place value, multiply it, then multiply by the place value that it is having, then write it down and add the two digits that are obtained. So when you add, the answer obtained is simply the required answer in our multiplication. Another example that we have, we have 380 multiplied by 49. So still we are following the same procedure. So we'll have 380 times 49. So the number in the ones place value is 9. So we are having 380 times 9. 9 times 0, we get 0. We have 9 times 8, that is 72. We write 2, carry 7. 9 times 3 is 27. 27 plus 7, we get 34. So we come down and write 380 times 9 is simply 3,420. So we have 3,420 as the answer that is obtained when we multiply 380 by 9. Then the next number that is in the tens place value is 4. So it means we are having 380 multiplied by 40. 40 is a multiple of 10. we said you start by multiplying the number by 4, then the answer you get, you simply add on the 0 that is there. So we'll have 380 times 4. 4 times 0 is 0. 4 times 8, we are getting 32. So we write 2, carry 3. 4 times 3 is 12. 12 plus 3, we are getting 15. Then remember we had 40, so we add on the 0. Then we transfer the details or the digit we've obtained here on our calculation. So I'll have 0. So when we add the digits, we have 0 plus 0, which will give me 0. Then 0 plus 2, which will give me 2. Then we have 4 plus 2, that is 6. We have 3 plus 5, that is 8. Then we have 1 plus, this is just 1, so we'll get 1 at that point. So this means that when we multiply 380 times 49, the answer that is obtained is 18,620. So those are the 3 methods that are used when we are multiplying the large positive integers. So when you are having large positive integers, then you have the 3 major methods that you are going to use. First of all, observe if you are having 10 in the multiplication. So if you have 10 in your process of multiplication or a multiple of 10, then simply multiply that number that you have. If you're multiplying by 10 or powers of 10, you count the number of zeros that are in that digit, then add on that given number. If you are having multiples of 10, then or the other powers, other multiples of the powers of 10, then you start by multiplying the number by the digit that is before the zeros, then count the number of zeros that are after that digit and add on your answer. Then if you are having numbers that need to go through the algorithm of multiplication, then go ahead and carry out the algorithm in that the digit in the ones place value multiplies the other number, then the digit in the tens place value multiplies that number. The answer obtained is added, and after adding, whatever sum you get is what will be given as the product of those given sum. So we look at an exercise that is involving multiplication of the positive integers. So those are that is the exercise we have, maybe just to add on what we have. So having that exercise, we can go through it together so that we get the solution to that given exercise. So the first question, we have 29 times 10. So when you're having to multiply by 10, we simply add the 10 or powers of 10. We simply find out the number of zeros that we have. So if it is only 1 0, like in this case, we simply add the 0 on our digit that we have. So we are having our digit as 29, but it is being multiplied by 10. So it means we have 1 0. So I'll add the 1 0 on 29 to get 290. So it means 29 multiplied by 10 simply gives us 290. The same is being applied on 4 times 100. 100 is a power of 10. It is having 2 zeros, so I write 4. Then after writing the 4, we add the 2 zeros to get 400. Then we are having 2,910 multiplied by 1,000. 1,000 is also a power of 10. So being a power of 10, we simply find out how many zeros are there. So there are 3 zeros. So we will simply write 2,910. Then after writing the 2,910, we add the 3 zeros that are there. So we have 1, 2, 3. So it means that 2,910 gives us 2,910,000. Then we have 17 times 20. 20 is a multiple of 10. So being a multiple of 10, we first start by multiplying by the number that is before the 0. Then we multiply by 10. So this is what we do. We will have 17 multiplied by 2, then times 10. 17 times 2 is simply 34. Then 34 times 10, we get 340. So 17 times 20 is simply 340. Next, we have 138 times 300. So 300 is a multiple of a power of 10, and the power of 10 that we are talking about in this case is 100. So we will have 138 times 3 times 100. So 138 times 3, we have 3 times 8, which is 24, carry 2. 3 times 3, that is 9. 9 plus 2, we get 11. Then we have 3 times 1, which is 3. Then plus 1, we get 4. So we have 138 times 3 is simply 414. Then times 100. So when we multiply 414 by 100, we will simply add the 2 zeros so that we have the 2 zeros after the 413, so that our answer becomes 41,400. Next, we have 37 times 11. So 37 times 11. We are going to use the algorithm of multiplying numbers, in that we are starting with the number on the ones decimal place, so that we have 37 times 1, and 37 times 1, any number multiplied by 1, you simply get that number. So 37 times 1 is simply 37. So we come down and write 37. The next number is 1, which is in the tens place value. So we have 37 multiplied by the digit in the tens place value, that is 10. So the total value of, the digit in the tens place value, which is 1, the total place value of 1 in that case is 10. So 37 multiplied by 10 is simply 370. So we come and write 370 at that position. Then after multiplication, we go ahead and add the numbers that have been obtained there. So we have 7 plus 0. 7 plus 0 is 7. Then we have 3 plus 7, which will give me 10. So write 0 and carry 1. Then we have 1 plus 3, which gives us 4. So it simply means that 37 multiplied by 11 gives us 407 as the required answer. The next question we have is 442 multiplied by 16. So we start with the digit in the ones place value. So the digit in the ones place value is 6. So we are having 442 multiplied by 6, which will give me 6 times 2 is 12. So we write 2, carry 1. Then 6 times 4, that is 24. Plus 1, we get 25. So we write 5 and carry 2. Then we have 6 times 4, which gives us 24. 24 plus 2, we get 26. So we come and transfer our details here. So we have 2, 5, 6, 2. Then we go ahead to the next digit in the tens place value. We are having 442 multiplied by its total value, which will be 10. So we get that 442 times 10 gives us 4,420. So we come and transfer the details we have here. So we have 0, 2, 4, and 4. Then after that, we add our digits. So in adding, we have 2 plus 0 is simply 2. 5 plus 2, we get 7. 6 plus 4 gives us 10. We write 0 and carry 1. So we have 1 plus 2, which is 3. 3 plus 4, that is 7. So what does it mean? It simply means 442 multiplied by 16 gives us 7,072 as the answer. Then another question that we need to solve is 1,026 times 33. So we have 1,026 multiplied by 33. So starting from the far right, we are having 1,026 times 3. This is the digit in the ones place value. So we'll get 6 times 3, that is 18. So we write 8, carry 1. Then we have 3 times 2, which gives us 6. Then plus 1, we get 7. Next we have 3 times 0. A number multiplied by 0 is simply 0. Then we have 3 times 1, which is 3. So the digit that is obtained is 3,078. So we transfer our figure at that place. The next digit is also 3 that we are multiplying by 1,026. So I have 1,026 multiplied by 3 is in the tens place value. So it means this is multiplied by 30. And being multiplied by 30, 30 is a multiple of 10. Being a multiple of 10, it means that I'll start by multiplying by 3, then the answer obtained, I'll add the 0 that is on that 30. So when I multiply 1026 by 3, we've already worked it out earlier on, and we are getting 3078. Then we have a 0 on 30, so we add the 0 on that 30 so that we get 30,780. So transferring my detail to this point, we are having, so we have 8 plus 0, which is simply 8. Then 7 plus 8 gives us 15. We write 5 and carry 1. Then we have 1 plus 0, that is 1. 1 plus 7 gives us 8. 3 plus 0 is simply 3. Then we finally wind up with the last 3. So it means 1026 multiplied by 33 simply gives us 33,858 as the required answer. So that is multiplication of numbers, positive numbers, be they small numbers or large positive numbers. That is the procedures that are involved when we are multiplying the integers. So the next thing that we need to look at is dividing positive integers. So we need to look at dividing positive integers and dealing with the remainders. First, it is important to note that division is simply the reverse of multiplication. So when you are doing division, you are simply doing the reverse for the multiplication that we've just handled. Previously, when we've been looking at multiplication, for instance, we talked about a number like, in case you are having 3 multiplied by 2 will give us 6. But we are talking about division. Division simply means the reverse of this multiplication. So what are we going to do? We are going to give the reverse, starting from the answer and looking for the whatever figure that has been multiplied with to obtain that given answer. So this is what I mean, that my answer is 6. What number is being divided by this 6 to obtain? We are supposed to get this number that is being multiplied by 6 to obtain 2, or I'm having this 6 being divided by a certain number to obtain 3. So that is the questions that we need to ask ourselves as much as we are dealing with division. So division, we are working out the reverse of the multiplication. So this is what is happening. What number can I divide by, what number can divide 6 so that I get 2? So what question am I asking myself? That this 2, for it to be obtained, then it simply means this 2 is the same. For me to obtain the 6, it simply means I'm having 2 multiplied by 3, which will give me 6. So it means this missing digit is simply 3. So that if I'm having 6 divided by 3, will give me the answer as 2. The same thing is happening at this point. I'm having here the answer as 3. Then my question is, what is this digit that is missing at this given point, such that if I have 6 divided by the digit, it will give me 3. Then we are saying that this is simply the reverse of multiplication. It means I'm having a number that when I multiply by 3 by that given number, I simply obtain 6. So the number that I'll multiply by 3 to get 6 is simply 2. So what are we saying? We are simply saying that division and multiplication are reverse operations. So whereas division, you are multiplying. When we looked at division, we said that you will start multiplying from the far right. In division, we are going to divide. We are going to start with the figure on the far left, because we are talking about division and multiplication are all reverse operations. So whatever we've been doing for the division, we are simply going to reverse. When it comes, whatever we've been doing for the multiplication, we are going to reverse when it comes to the division process. So we look at a case that has a reminder when we are dividing and it has a reminder. A very good example that we have is when we are having 79 divided by 7. This is what is expected. So we have 7 into 79. We've said that with the division, we are starting from the far left. So we are starting with the digit that is in the far left, that is 7. So 7 will divide 7, that is once. Then we have 1 times 7 will simply give us 7. If we subtract, then we get 7 minus 7 is simply 0. So the remaining figure that is in the far right is 9. So this means that 7 divides 9 once. So 1 times 7 is 7. Then when we subtract this, we are going to get 2. So looking at that case, then we have some terms that we come up with. The first term that we are going to define in that case is so we are talking about the quotient, and we are defining the quotient as simply the number so the number of equal sized groups that are obtained. So this number that is obtained in the example that we've just looked at, an example in this case, looking at this example, the quotient in this case is 11. Then the next term that we need to look at is what is known as dividend. So we are talking about dividend, and we are simply defining the dividend as the total that is being divided. So that number that is being divided is whatever we are referring to as the dividend. So we are having an example in whatever we've been looking, and the number that is being divided in this case is 79. So what do I say? Then we are saying that in this example that we have, 79 is our dividend. Then the next term that we need to define is what is called a divisor. a divisor, we are simply referring to it as the size of equal groups that are obtained. So in this case, the size of equal groups that we have 7 size of equal groups of 11 in this example. So what does this mean? That in the example that we have, then our divisor is simply 7. So in this case, the divisor is 7. Then finally, we have this digit that was left after the division process. The digit was left hanging. That digit is known as a remainder. So any amount that is remaining after division into equal sizes, then that amount that is remaining is referred to as a remainder. In this case, the example that we've been handling, then our remainder is 2. So those are some of the terms that are used in the division process. We are having a quotient, we have a dividend, we have a divider, then we have a remainder. So those are the terms that will be used throughout the division process. So we can look at the process of division, but before we look at that, it is important for us to note that when we are looking at multiplication of positive numbers, we looked at the commutative rule and the associative rule. With the commutative rule in multiplication, when we are dealing with multiplication, this is what we said, that if I have a figure A multiplied by B, then it is simply the same as B times A. That the order of multiplication doesn't really matter. An example was, when we look at 2 times 3, is simply the same as 3 times 6, 3 times 2. 2 times 3 is 6, and 3 times 2 is simply 6. That is the commutative rule when it comes to multiplication. But when we apply this rule in division, you find that it doesn't apply. So an example is, if I'm having A divided by B, A divided by B, we are saying it is not equal to B divided by A. So commutative rule does not apply when it comes to division process. An example could be, if I'm having 4 divided by 8, and on the other side we have 8 divided by 4. So what does it mean? 4 divided by 8 is simply 0.5. But 8 divided by 4, we get the answer is 2. So it simply implies 0.5 and 2. These are totally different figures, and that is why we are saying that the commutative rule is not applicable when it comes to division process. We can look at another example, maybe. We are having an example like when we have 6 divided by 5. 6 divided by 5, when we look at the division process, then we have 5 into 6 is 1. Then we will get 1 times 5, that is 5. When we subtract, we get 0. So when I add a 0 and place a decimal point there, 5 goes into 10 2 times, so that we get 10. When we subtract, we have 0. So it simply means 6 divided by 5 is 1.2. But on the other side, I have 5 divided by 6. When I have 5 divided by 6, you find that 6 cannot go into 5. It cannot divide 5 fully. So what do? We write a 0 and place a decimal point, then add 0 on 5. 6 into 50 is 8 because of 48. So 8 times 6, you get 48. 50 minus 48 is 2. So when we add a 0 on that point, so that we have 6 into 20, that is 3 because of 18. When we subtract 20 minus 18, we get 2, and we find that that is simply given as a recurring decimal. But the fact is, on this side, we are getting 0.83. The 3 is recurring. But if we compare on the left-hand side and the right-hand side of our equation, you find that we have 1.2 and 0.83 that is recurring. This means that 1.2 and 0.83 are not equal. So what am I saying? Commutative rule is not applicable when it comes to division. It is only applicable when it comes to multiplication. The other rule that we looked at when we were multiplying numbers with the associative rule, we were talking about a pair that you start with doesn't matter. For instance, when we are having A times B times C, if you are starting with the first pair, that is A times B, then finally multiply by C, it is just the same as starting with B times C, then finally multiply the answer you obtained by A. But this rule doesn't apply when it comes to division. We can look at this better when looking at example. A very good example is when we have such like numbers. Nine times 3 times 2, I'm starting with the first pair. 9 times 3 is simply 27. Then multiplied by 2, we get 54. On the other side, if I start with 3 times 2, 3 times 2, we get 6. Then multiply by 9, 6 times 9 is simply 54. So what do we say? That the left-hand side and the right-hand side, when it comes to multiplication, it doesn't matter which pair you start with, the answer is simply the same. But let us use the same example when it comes to division and find out what happens. So we have 9 divided by 3 divided by 2. We are starting with the first pair. When I have 9 divided by 3, then it means the answer is 3. Then divide the answer by 2. So 3 divided by 2, we are getting the answer as 1.5. On the right hand side, we have 9 divided by 3 divided by 2. So we are starting with the second pair, which is 3 divided by 2. So when we have 3 divided by 2, we are getting 1.5. Then we have 9 divided by 1.5. So we will have 9 divided by 1.5. We start by removing the decimal point. So I'll have times 10 multiplied by 10, so that I have 90 divided by 15. 90 divided by 15, what we are having is 15 into 90, that is 6, to obtain the 90. So we get 9 divided by 1.5, the answer is simply 6. So we get that on the left hand side I have 1.5, on the right hand side I have 6. So it simply means 1.5 and 6 are not equal. So the associative rule does not apply when it comes to the division process. So we simply go through the short division algorithm process, and we'll look at it by simply looking at the examples that we have, so that we get to understand what is the division process that we need to go through. So we have the first example, that is 413 divided by 3. So 413, through the short division algorithm, we have 3 into 413. We said that we are going to start from the far left. So we have 3 will go into 4 once. 1 times 3 is simply 3. Then when I subtract 4 minus 3, we get 1. So this remainder that we get, we bring it to the next digit that we have, and the next digit we have is 1. So when I bring 1 to the remainder, then we get 11. 3 into 11, that is 3. 3 times 3 gives us 9. 11 minus 9, we get 2. So this remainder we bring onto the remainder, the remaining digit, and the remaining digit we have is 3. So when the remaining digit is brought to the remainder, which is our 2, it forms the number 23. So we have 3 into 23, that is 7. 7 times 3 gives us 21. 23 minus 21, we get 2. So what do we say? That 413 divided by 3 simply gives us 137, remainder 2. The second example we have, we have 139 divided by 2. So we have 2 into 139. In this case, the first digit we have on the far left is 1, and you find that 1 is a figure that is less than 2. So we will not be able to divide unless we bring in the second figure. So the second figure that we have in this group is 3. When we bring 3 closer to 1, then we form a digit that is 13. So 2 into 13 is 6. 6 multiplied by 2, we get 12. 13 minus 12, the remainder is 1. So this remainder, we bring in the remaining digit or the next digit, and our next digit is 9. So we find that 2 into 19, that is 9. 9 times 2, we get 18. 19 minus 18, the answer we obtain is 1. So 139 divided by 2 gives us 69, remainder 1. So we want to conclude by looking at the mental division process, or the mental processes in the different ways in which the mental division process is applied or it is done. The first mental process is simply using the knowledge in the multiplication tables. So when you have the knowledge of the multiplication table, then it gives you the ability to divide a number when it is a number that is appearing in the multiplication digits. So in this case, for instance, when you have 63 divided by 9, 63 divided by 9, it simply means you apply your multiplication tables. When you are multiplying, when we talked about, we were introducing the division, we simply said it is the reverse of multiplication. So it means there is a figure, when I multiply by 9, I will obtain 63. And this figure is simply the figure is 7. So when we have 9 times 7, then we will obtain 63. So what does that mean? 63 divided by 9 is simply 7. So this is using the knowledge in the multiplication tables. Then the next mental technique that is convenient when we are using is when we are having multiples, the multiple of the divisor by adjusting or subtracting. So when you could either decide to adjust the divisor by subtracting or adding, so that you get some multiples that are easily worked out. An example is a digit like 84. When we have 84 divided by 3, I can adjust this by having 90 minus 6. 84 is simply the same as 90 minus 6, so that I'll have 90 minus 6 divided by 3. So that is 90 divided by 3, then minus 6 divided by 3. So I work them out. 90 divided by 3 is simply 30, and 6 divided by 3 is 2. Then 30 minus 2 gives me 28. So that is by the distributive method of division. Then finally, the last method that we have when you are calculating mentally is when you have both of the numbers being even. If both of the numbers that are involved in that given equation are even, then you can simply half the equation. By even numbers, we mean that these are numbers that are divided by 2. For instance, if I'm having 44 divided by 4, 44 is an even number, 4 is an even number. So I can decide to half the two digits, so that when I have 44, I'll get 22, and when I have 4, we get 2. So you're simply having 22 divided by 2, and 22 divided by 2 simply gives us 11. So what are we saying? That it is very much important for us to follow the rules. As we are concluding, we are simply saying we are supposed to follow the rules up to the letter for you to obtain the correct answer when it comes to multiplication and division of positive integers. Thank you.